All right, so I'm gonna give you a couple concepts about Java, programming. So Java is object oriented. What is object means? Object is just a thing. Right? Car is an object. A person could be an object. So there are two types of variables. And like in math, you know what a variable is, right? Trying to solve for x and stuff like that. Let's say you have x equals 2. So you assume x holds a number, right? And that's the answer. Well, the computer is going to read, we don't call it equal sign in computer science. You know what we call this? Equal sign instead? Has a name. We call it the assignment operator. And what the computer does, evaluates everything that's on the right side of the equal sign. It could be a number, it could be a law, an expression, it could be a lot of things. Whatever is on the right side is going to be evaluated. And it's going to come up with a result. That result comes back in a CPU cycle. That's why I want you to watch those videos to learn about CPU cycles. And then it gets assigned to whatever's on the left side of the equal sign. So this whatever is on the left side of the equal sign will be a variable. And the computer reads from the right side of the equal sign and puts it on the left side, right? Mathematically speaking, you can do this, right? But not in the computers, because the computer is going to say, whatever evaluates on x, I want to assign it to the number 2. But 2 is not a variable, it's a constant. So this can't happen. All right? So, all these variables are held in memory. And the computer needs to know how much memory you need. Right? I mean, if you're going to hold a whole book in memory, you're going to need a big chunk of memory, right? What happens if you run out of memory? Anybody knows? Like you only have like 1 gigabyte of memory, which is really sucky. The computer just dies. Get the blue screen of that. No.
Would you get like an error code saying that there's not enough memory on the unit?
So, all right, so we have this thing, right? The motherboard. And here's your CPU, and here's your RAM. And then you got all the peripherals, right? And all this other stuff. If you ever open a computer, you see the motherboard. And the CPU is going to have this big fan and heat sink because it has to be really, really cold. So, you ever heard of overclocking? You know what that is? Makes you, yeah.
When you make the processor go faster than it's normally intended to.
What happens if it goes faster?
Creates more heat.
Creates more heat, right? And if it's too hot, there's gonna be a hole in there. Instead of CPU, we're gonna call it RIP, right? Because it dies. So, the CPU, nowadays, it's more than one CPU. You have more than one core. So there's one CPU sitting on top of the other. And people try to compress as much circuitry into one spot and it generates heat. Electricity generates heat. So we had a CPU, a bunch of legs on all the sides, And then there's a core here, there's another core. You got multiple cores. So when they say core, it means the CPU is actually more than one laying on top of the other, really thin. But then the CPU can only do one thing at a time, at least one CPU. It can only do one instruction. It's like very narrow-minded. It can, if you say blink, that's what it does, blink LED. It doesn't know what it did before, why it did it. It doesn't know what's going to do next. It's like very linear. Sometimes the CPUs have so much circuitry, you can actually split it in half and stick two concurrent instructions. That's the max you can do. When you do that, if the CPU is capable, you know what that's called? Anybody? It's called hyperthreading. That's when the CPU can handle two instructions. If it can only handle one, so it's not capable of hyperthreading. So if you go on your computer, open your task manager, you can see in the processors, in the performance, this particular has 4 cores and 4 logical processors, which means it's not capable of doing hyperthreading. The speed is how many instructions the CPU can handle per second. So this particular CPU looks like it's oscillating between about 3.5 gigahertz. Hertz is the last name of the guy who came up with the idea of measuring the frequencies. And it says I can do 3.5 billion instructions per second. That's pretty good. So, although it says maximum speed 3.19, what's the current speed? Oh, it's higher than that. Maybe it's overclocked. Maybe we get new computers pretty soon. So, going back to my questioning. So the CPU, if you look, has a bunch of registers. And they have names. They got AX, BX, EX. That's how they abbreviate it and so on. They also have mini memory. As this one you can go online and see what an Intel i5 6500 CPU specifications are. But it will have like mini flash RAMs there. Maybe it has 3. So they call it level 1, level 2, or level 3 cache. What this cache is, it's simply the CPU, the speed is in gigahertz, right? If you click on the memory, the RAM, does it give me speed there? Yeah, it's right here. What's the speed of that RAM? If you can see it. It's 2133 megahertz. So it's quite slower, 1/10 the speed of the CPU. So these cache things, the idea of this cache thing is to keep the instructions it needs most frequently here, rather than going to the RAM that is at 10% of speed of the CPU. Plus there's a distance to travel. So the level 1 is really small. Then it puts what's using the most, hopefully 70% of the time is everything that it needs, it's inside the cache. If it's not here, it has to go to the RAM. And if he finds that it has to go to the RAM quite often, then he swaps them, instruction, puts them on the RAM. You don't get an error message or a warning, you're running out of cache in your CPU. It just goes to the RAM. The RAM runs out of space, it's also limited, and then, you know what RAM means, right? Random access memory. So if it's not here, it goes here. And that we call virtual memory. It's in your hard drive. And if you have a conventional hard drive and you're out of RAM, guess what happens? You can hear that thing spinning. And the computer gets really slow. So those are stuff are in the videos anyways. We're going back to this. Variables are stored, well, in the RAM usually. It allocates as much memory as you need. If you say, I'm gonna need to hold a whole number, the computer needs to know how much memory do you want. Can I erase this? Alright, let me erase this. So, that was a crash course of CPU. So if I have a whole number, the computer needs to know how much memory does it take to hold a whole number. So what does the computer talk? What's the language of the computer? Anybody knows? What is the machine language?
Binary.
Binary, right? Bi means 2, right? So it only takes zeros and ones. That's the lowest level. Or also known as first generation language. So back in the old days, they will have switches, like light switches. And that's how they program. And trying to debug that thing was like jump from the Coronado Bridge, you know? And of course, people were amazed that they were able to find the square root of a number doing that. You know, I don't know how to do a square root of a number. I use my calculator. But back in those days, the computers were really, really limited. All they had was binary. And then instead of switches, they improved. They call it punch cards. So they grab this cardboard card and they punch holes at equal distance. I mean, if it's no hole, it's a 0. If it was a hole through it, it was a 1. So there's this needle going in, and that's how the computer programmed. I mean, the Apollo 11 had, I don't know how many computers in the module. When the PlayStation 2 came out, it was had more computational power than the whole spaceship. You know, and now we got PS4. So they say that every 2.5 years or whatever it is, that technology is either half the price or it's double the speed or something like that. I don't know. It's called Moore's law. You can read about it. I'm not going to ask you about it. It's just trivia. Unless you go like a Jeopardy or something, you want to know those things. So, but still, binary was too hard to comprehend. So they came up with stuff to move around the CPU and the RAM. And they call it a second generation. And usually, it had a command, like a type command, and it only had 2 parameters. And the parameter was with separated by commas. And all it says was move, I don't know, usually x to bx, maybe something like that. So move whatever it is register hat to this one, Omura value, and still does. That's called assembly language. So the assembly language is a low-level programming language. I mean, you can do anything with this. I mean, it's super fast. If you were to write drivers, you will use that. Combination of C and assembly. I don't know nowadays, but when I was in school, like Sony PlayStation was all in C. It was not like a IDE or anything. It was all in. I did it in Notepad, and it's hard to debug, but you want stuff to move quick, so you had access directly to the hard drive or to the hardware. So imagine you're playing and then you're gonna get shot and then your character freezes and then you die. That sucks, right? So you want that thing to move quick. So that's when you use assembly. But then they said, well, we don't need it to be that fast. My computers are getting faster and faster, right? Now I can calculate the square root in no time. So they came out with another one, a third generation. And this third generation, because this was called low level, this is a high level programming language. And that's where we fall into. That's Java, C++, Visual Basic, and so on. So what this high level does, it converts your code into a low level. And the low level converts it into binary. There are more too. There's 4 level or 4 generation. And that's pretty much the database stuff, SQL. And then there's the natural generation or 5th generation, which is like natural languages, like the way you speak. And the Prolog is 1. But we're gonna be here. Now, I recommend that you go and learn databases too, because unless you are a really, really good game programmer, trying to find a job without knowing database is hard. At least in programming. You could be a good hacker. So, anyways, questions? Alright, so we're going back to this. Variable. I need to know how much memory I need for a whole number. So the computer, if you look at this one, this computer has Windows 10. It has a 3.2 gigahertz processor, has 16 gigabytes of RAM installed, and it has a 64-bit operating system. What is that? You know, you could have a 32-bit operating system, 64-bit. What is that? What does that mean? You know, so what it means, here's my CPU, right? And it has circuitry that comes in and stuff that comes out. And there's some circuitry internally, right? So, binary, it means it's just 2 values, right? 0 or 1. Alternative, what other words could we use? For instance, if we convert this to switches, this switch is on or this switch is off, right? You can say on or off. There's another expression called Boolean, which means either true or false, right? So, how many bits do you need to represent true or false? Just one bit, right? It's either 0 or 1. How many bits do you need to represent hello world? I don't know. So it will be whatever number of letters divided by 8. Well, each letter is 8 bits, so it's a byte. Talk about bytes. But anyways, so 64 bits means the computer doesn't go and grab, oh, I only need 1 bit, no, I need 2 bits, no, I need 10 bits, doesn't know. He only grabs, it's like a bucket, always the same size. So every time it reads an instruction, grabs the same size. Every time it executes an instruction, every time it saves anything, everything is just the same size. That is 64 bits. So it's gonna be 64 bits instructions. So that 64-bit operating system means 2 things. Every instruction is 64-bit. Every memory address, as small as it can hold, is 64 bits. If you need 65 bits, for whatever reason, it's gonna go to 128. So it's just always 64-bit chunks. Yeah.
You said one word is just going to be 64 bits, no matter what.
Yeah. So that's what's called the word size. Word size. 64 bits. That's what it is. Yeah.
Sorry, what is a bit exactly?
0 or 1.
0, 1. 0, 1, that's 1 bit.
Yeah. So if I combine 8 bits, so I got combination from all zeros to, that's a byte, right? 8 bits equals 1 byte. So how do we measure our memory? In bytes. I got 16 gigabytes. So I basically have 16 times 8 bits available. And of which everything has to be chunks of 64 bits. So, yeah.
Okay, well, the bits, they transfer to the gigabytes, or is that like something completely different?
No, 8 bits is 1 gigabyte, 1 byte.
1 byte, and then you just add those up, that turns into gigabytes and stuff like that?
Well, giga means billion.
Right, so it's like billions of the bytes.
Yeah. So, well, this 64-bit it's been around since XP, I think. Before that was 32 bits. And before that, Windows 95 was 16 bits. And the DOS was 8 bits, or 1 byte. Bill Gates said, oh, my new operating system has 1 megabyte of memory. You will never need more than 1 million bits. And that's how he sold his DOS program back in the 80s. So, of course, we always need more and more. It's like your closet space, right? You're like, oh, I will never fill that up, and then all of a sudden it's like, I need more. Well, at least me. I mean, like, I mean, if I had a 3-car garage, I'd probably fill it up and then I need another car. Maybe a car collector. That'll be cool. I want to get a project like an Impala from the 50s. Anyways, so anybody has Windows 7? That's still around, right? Windows 7 is still around. Still supported. Well, Windows 7 has the 2 flavors, 32 bits or 64 bits. So, how many numbers can I represent with 8 bits? Easy. 2 to the 8. Because it's binary, I have 2 options, right? 0 or 1. And how many of those I have? I have 8, so 2 to the 8. That is 256 numbers. So that means I can represent numbers from 0 to 55. Why? Because 0 is a number. If I started at 1, I will end at 256. So this was the original design, I don't know, back in the 60s, 70s, 60s probably. Came up with the byte, and they came up with this byte system. So it was too hard to say 8 bits. The only time you use the higher is when you want to sound bigger. Like when you buy internet, right? Oh, your download speed is whatever megabits per second, because the number sounds bigger in bits and bytes. So when Cox Cable tells you you're gonna get 20 megabits per second, so you're telling, I'm getting only 2.2 megabytes per second. And no, you're getting 20. Make sense? All right. So this thing is 256 numbers. So basically, it's what the computer transmits. Chunks of 8 bits was the original. Now it transmits more, but 8 bits, and each number had a purpose. So when I only had 1 bit, if I had to represent true or false, we said 0 is false and 1 is true, right? So, but if I have 8 bits and I do something like this, is that true or false? Why is that? So if it were all zeros, it would be false, right? Are they all zeros? So if it's not false, what is the next? True. So anything that is not all zeros is false. Also, let me erase this. This all zero thing, doesn't matter how many bits you have. You know, this is false here. Also, depends what you use it for, it will be a null. Or nothing. Or we call it a null terminator. That should be the name of a movie, right? Null Terminator. So, and then let's start giving values to all different numbers. Ever seen an electric typewriter? No? You can see one at the library. But so You put paper and then you roll it. There's an option that you can have the carriage, and when you're typing, to go back to the beginning of the line, but stay on the same line. That's called a carriage return. If you wanted to move to the next line, that was a new line. So if you hit enter in your computer, guess what you're doing? You're doing two characters. You're doing the carriage return and the new line. But when you're typing, it goes to the next line, right? So those, I think one is number 10 and the other is 13. Which one is what? I can't remember. So, like the escape key, I think it's number 12. They gave it an assignment to the keyboard. So all those 256 values in this table had a name. You know what they call it? We call them Ascii. And I don't know, American something code, international, I don't know. You can Google it. Google knows everything. It knows so much about you that even that gives you the answer before you ask the question. I know many people like that. Anyways, so this Ascii code holds all the Roman characters or Latin characters. Meaning, you'll hold the accents on the letters and the dots on the letters. So any Western European will be will be in the Ascii code. Why did he include the Russians? Oh, because there was a Cold War going on, right? But yeah, I can type in a Russian keyboard. I had to the D is not in the same spot because it looks different. So anyways, so every letter has an accent. It has an Ascii code. So if you look at my last name, it has an accent on the O. If you have Notepad open, you can hold the Alt key and type the number 162 and then release the Alt key and it'll show up. Any Ascii code, you can just press the Alt key and you can go to this website, ascii-code.com, and let's see. And there's a list. See? So look at this one. Decimal, hexadecimal, binary, symbol. Number 7 is a bell. Means a bell. So if I go to Notepad and type Alt 007, it beep. That's what the bell does. So eventually, what about numbers? The numbers itself. Well, look at number 0. What's the ASCII code of number 0? 48. So 0 is not really 0. It's 48. What does that mean? That means when you press the number 0 in your computer, it's not transmitted as a number. It's transmitted as a character. So like 0 is a letter. Everything is like a letter, see? Uppercase A is 65, lowercase a is 97, and so on. Questions? So, going back to this, and I keep trying to give you crash courses here. Yeah?
Where is this table stored?
It's hard-coded. It's called a truth table, actually. It's just hard-coded. The computer receives the bytes and it's how you interpret it. I mean, if I press the uppercase A, that means I press the shift and the A, right? And the computer doesn't transmit A, it transmits 65. Because it transmits a binary sequence of between 0 and 255. It's just a number. Computer only talks numbers. How we interpret the numbers, I mean, in memory, the number 65 or the uppercase A are stored exactly the same way. Is how you interpret it. So, so, and bit, and the number here I, x, the variable x, is supposed to hold a whole number. So we call that whole number, let me erase this. An integer, or just call it int. An int is a 32-bit whole number. So before I can assign value to a variable, the variable must exist in memory. Basically, I need to allocate memory. And when I allocate memory, I gotta tell how much I want. So if I want to hold a whole number, I'll get an integer. That means I got 2 to the 32-bit numbers, right? And that's roughly a little over 4 billion. So if you have a 32-bit operating system, you can hold up to 4 gigabytes of memory. That's the max. So if you want to put more memory, it doesn't matter because the computer cannot hold that many addresses. Well, let's put a 64-bit operating system. Well, then now every instruction instead of 32 bits is going to be 64 bits. That means everything is going to use double the space. So if I do, let's see, calculator. So 2 to the 32 is 4,294,967,96. That's the max of memory I can have. But if I do the next chunk, 2 to the 64, it's a very large number, right? I don't think computers can handle that much RAM right now. Someday they will, probably. And then we'll probably have to go to a 128-bit operating system. So now with 64-bit, I can address quite more locations. So in the RAM, first bit is bit 0 and then it goes all the way till the last bit. Well, most likely this one has 16 gigabits. So let's stop at 15,99999, whatever. It's not really 16. It's actually, so it will be, well, it is 16. Everything gets double, right? So 2 to the 16, it is that. So it will be actually if I have 16 bits instead of 8 bits for my Ascii code, my 8 bits can represent 256, right? So 8 bits bits, I get my ASCII. I can hold only the Roman characters and some other numbers, and like you saw, escape, space bar, and all those things. Well, what if I have 16-bit? I'm not limited to 256. I can have 65 by 36. And that has another name. We call it Unicode. Universal code. And this Unicode thingy is simply double the number of bits I can handle, so I can accommodate every human language. So now you have Asian characters, you have Middle Eastern characters, you can have any kind of characters. So Java uses Unicode. So, and we'll go until 11, we'll go 10 more minutes, and then we'll take a break, because my mouth is getting dry. So, what if I need more than 32 bits for a whole number? There's another one called long. I use 64 bits. What if I only need 1 bit for true or false? We say it's only 1 bit, right? True or false. But is the computer going to allocate 1 bit? No. It's going to allocate the word size. So the other 63 bits or 31 bits, they're just wasted. So what do? Well, try to put all the bools together so you don't waste that much memory. What if I want just one character, the Ascii code? Use a character. And there are other types. The only ones we're going to use now in this class, we use a double. What's a double? Well, if an int is 32 bits, let's double that, 64 bits. But I want to split it. I want to use one side for whole number and the other side for decimal values. So we use 4. So we can use the dot, and there are 3 more. I mean, you can read about those. You can have bytes, you can have real, I think is the other one. It doesn't matter. So if I'm holding numbers, I can figure out what size memory I need, right? But what if I want to store addresses? What do you mean I want to store addresses? Memory addresses. I want to store memory addresses. How many bits do I need for this computer? How many bits do I need to represent an address? The 64-bit, right? So this doesn't exist, this type. I'm just gonna write address here. So it's a 64-bit address. So remember, in the RAM it goes from bit 0 to whatever bit number we have. But this has a name in Java. You know what that name is? It's an object. So all these things, the ones I know, the size, plus the ones that I mentioned, they're called primitive. So all these things are primitive types. One character, I know how many bits I need for one character, I only need 8, right? How many characters how much memory space do I need to hold the whole Java book you're having? I don't know. You have to count it, right? Do I care? No. But what if before computers, libraries had this index card, and you go find the book in the index card, and then you find, oh, my biology book is in, I don't know, aisle 20, shelf H, or whatever, you know. You go look for it there. So basically, that little card only had the address where the book was, right? Now you do it in the computer, but the principle is the same. So, I don't know how many characters I'm gonna need to store my whole book. But I want my whole book to be together, right? You don't wanna be page here or page there. Imagine trying to find that in the library, will go crazy, right? So, the library is kinda full, whatever, you find a space where the whole book fits, and then you write down the address, and then put it in that little index card. So this is what this is. This holds an address where whatever you have is not primitive, it's gonna be at in memory. So remember, the RAM is random. That means it could be anywhere. It could be above, below, it could be in another chip. You can have 8 chips RAM in your computer. So this object holds the address for any object. What if the object doesn't exist? Oh, let's say it differently. What if I allocate the 64 bits to hold an address, but I don't have the address yet? I haven't gotten the book yet to put on the shelf. So, what should be the value? Well, it should be all zeros, right? What we call that? Null. So when the object is pointing nowhere, we say it's a null. If it has a value, it should be an address. So the operating system job is to schedule things and select this referee. Okay, Word's gonna have this much memory and it's gonna have this section of the RAM, and then the internet's gonna have this section of the RAM, and then whatever. Each program have space allocated in the RAM. And it's the operating system's job to manage all that, keep track. So what happens if the object is trying to access the address that belongs to another program? You get yelled at. You get this error that says memory access violation or whatever, because it doesn't belong to you. So we say Java is an it's a object-based programming, because everything is by objects. I mean, trying to do everything in just primitive types, you can, but it's a monumental task. And the more complex the programs are, you're gonna go crazy. So we create objects to make our lives easier. We're gonna talk a little bit more about those when we come back in 10 minutes. Okay? All right. So, let's talk about Java a little bit. Java was, well, each hardware, you know what drivers are, right? So they respond to specific instructions. So this guy wanted to write software for microwaves and refrigerators and stuff like that. And they wanted to make them all, just write one program and it'll work with all brands, microwave, whatever. So come up with this language called Oak. But the Oak wasn't really a machine language, because the machine language and instruction for camera is different than the instruction for a microwave, although binary might be the same, but they might mean something different. And didn't expect that's going to be so widely used. So he changed the name from Oak to Java. And the way it works is they created something called Java Virtual Machine, or JVM. This JVM is a program that is specific to the hardware where it's running. So the Java Virtual Machine for a iMac is different from a PC, and it's different from a printer and whatever, right? So the idea is I write a Java program. It comes into this pseudo machine language that this JVM is going to understand. And when it runs in that specific hardware, this JVM is going to translate that pseudo machine language into the actual machine language of the hardware it's running. So this pseudo machine language is called Java Bytecode. This Java bytecode is what your code is translated into, and then it's run by this virtual machine. So, you're going to be writing programs in Java, and that program should run in a Mac or in a PC. So this layer, there's an extra step here, right? So the CPU, like we saw, can only do one instruction at a time. If you had an instruction already binary to do, just execute it. But in here, it has to do a couple more things before it can read the instruction, because it has to translate it from this to this and then to this to machine. So that's like an extra 3-4 steps. Those are an extra 3-4 CPU cycles. So Java is going to run slower than a C++ program, because C++ you can write it directly to a machine language, but you cannot run a C++ program written for a PC in a Mac or in a microwave. So it's a trade-off. I mean, computers are fast enough that it doesn't really matter. Still, it is. You pick the language you're going to write your programs based on the target hardware and the audience, I guess, will be. So, let's talk about structure real quick. Let's say I have a box. And this box is, instead of laying it flat, I laid it on the side. So the box looks like this. And it has lids here. I can put stuff inside that box, right? I can put another box. I can put another box in here. And those are the lids. I can put another box on the top too. And let's say I'm an eBay store. And I gotta ship this stuff, whatever you buy. Can I ship stuff with the box open? No, right? Can I close it? Can I close the blue box before I close the red one? No. So, can I have a movie here, a DVD, let's say, or a DVD from the X-Men? That's what that box has. This one has another copy of it. They're the same movie. I have two of them. Is this the same as that one? No. They're in two different boxes. They're physically two different DVDs, right? So, if I'm inside this box and I say, hey, give me the X-Men movie, will it grab this one or will it grab that one? We'll grab the one inside that box, right? If I'm inside that box, can I see what's in here? No. Right? So, we say whatever we're inside this box. Now instead of calling DVDs, we're gonna call it memory or variables. This is only visible from inside this box, right? So we call this local variables. That is only visible inside this lids, right? What if I have over here a shipping label? Is the shipping label different for this box and for this box? There's one for all of them, right? And if it were to be a variable, we'll say, actually that's a global variable, because it's seen by everybody. Well, actually it will be inside the box only. So we call it a class variable if you want more technically correct. So, can I overlay the boxes? No, I can't put this box halfway inside this other box. Yeah.
Are you using that as an example of like modularization?
Yeah. So, Java or any programming language, it does it this way. I mean, inside doesn't matter which box is top, which box is in the bottom. They're all inside the box, right? So, Java needs a point of entry and needs a main box. I mean, you can have 20 boxes, but there's one that has your invoice inside or whatever when you ship it. So, we call that a class. I would say it's public because everybody can see it. And then we give it a name. You know, instead of calling it box, I'm gonna call it my class. And instead of box lids, it's gonna have curly brackets. So that's my opening curly bracket. That means I need to have a closing lid. I need to have a closing curly bracket. You follow me?
So public class is my class.
Hmm?
Which is the public class is my class, which is the big box, right?
Yeah. So inside, it's like my shipping container, if you will. And inside, if you have a bunch of boxes and you have to put stuff in order, you're gonna go, there should be one that says which one you open first. That box that you open first is my first point of entry. So if you're traveling, it is not coming from international flight, it'll tell you gotta go to customs first, right? They'll point you to customs. You gotta go there, you can go get your bags first. You gotta go through, get your passport or whatever. Which for some reason, the French are crazy. Oh my goodness. They asked for New Year's, I went there, and it took me an hour and a half to get in, and then an hour and a half to check out. Here you don't have to check out, you just go. And then my flight there was a bomb threat, the airport was locked down, it was chaos. It's New Year's. And so I couldn't go. So I was trying to run away to London, catch a train and take off out of London because it was gonna be like 5 days before I could leave France. It was stupid. And I had to go again to passport control for 45 minutes. I'm like, I haven't left. I went to the gate. I had a Starbucks while waiting for the plane. No, you gotta get your passport stamp. This is ridiculous. And then finally I get it. Where's my bag? It's in lockdown. You can get it in 5 days. I'm like, I can't wait 5 days. So I go in the train, and then I had to go to the train, and they're like, oh, you gotta go passport control again. I'm like, this is so stupid. I got my bag a month and 1 day later. They're like, you abandoned your bag. No, you didn't want to give it to me. Oh, that's Delta's responsibility. No, it's American Airlines. No, stupid. Cool story though. It was fun. It was cold. Anyways, so I need a point of entry. The first port of entry, I'm gonna explain to you in a later time what each word means, but it looks like this. So I have another lid here, open and close. And I need to have the same number of opening lids as the same of closing lids. And for the first programs, we're gonna have one class. We're gonna just write, everything will be command prompt based until we get to GUIs and we get to do cool stuff, and then you're gonna have a bunch of them. And then the computer always needs to know where it's going to come in first, because then it doesn't know which one to start. So this, like this syntax, must exist. I mean, you need to have a public static void main, and oh, those are parentheses. What do parentheses mean? Well, parentheses. Same thing, I need to have an opening and closing parentheses. But those parentheses are like envelopes, I guess. And inside it has it could be nothing inside the parentheses, or it could be, like in this case, something in it. We call those arguments. So this arguments, or parameters is also another name. What's the difference between parameters and arguments? Parameters is what something is expecting, and argument is something I'm sending to whoever is expecting. Like for instance, I had to pay taxes this year. Just hated it. So the IRS expect as parameter a check. But I actually wrote the check, well, I haven't, but I filed an extension. Gosh, it was like $9,000. I didn't expect that. I thought I was gonna get money back. Now I had to pay interest on that because my CPA told me I was gonna get money back. That is good though. So the actual check that I write is the argument. It's the one I send to the IRS. The IRS is expecting one check. So this is like the one check they're expecting. And they're expecting one check from everybody, right? It's the same parameter. But everybody sends a different check because they're all from different bank accounts. So those are their arguments, right? It could be one check. It could be a bunch of checks, or besides your check, you want your firstborn. I don't know what else the IRS wants. So that's called, when you have one or multiple, even zero, everything, the list of all the parameters they want is called parameter list. So they say time is money, and if IRS wants money, can you send time? I work for you. I don't know. I guess it's like when you can't pay the restaurant bill and then you gotta go wash dishes. Okay, so this has parentheses. Every time you see a parenthesis, like this next to a name here, this whole thing has a method. So methods have a method name, this is called main, and they're followed by parentheses. And inside those parentheses, they expect a parameter list. Capish? Yeah.
So it's made up, the parameter list is made up of arguments?
The parameter is what they're expecting. The argument is what you send to that method when you call it. So I gave you the example of the check. Maybe not a good analogy, but that's the only thing I could think of right now. So far so good? So remember when we had x equals 5 before? Is x a variable or a method? A variable. Why? It doesn't have parentheses. That's all it is. So I said before you can use memory, you have to ask for it. It's like my nephew just grabbing ice cream. I'm like, no, you gotta ask and say please, right? So you gotta ask for stuff before you can use it. So how do you ask? Well, I need to ask memory. Well, number 5 was just a number, so I can ask for an integer. And what do you want to call that integer? I want to call it x. Are you done? Yeah, I'm done. How do you know I'm done? Well, you need to add end of statement or end of instruction as a semicolon. So this is your end of statement or instruction. I mean, you're making a statement, the computer needs to know when you're done. What's the end of it? Why? Because what if it's really long? I'm running out of space. I go on the next line. So if it wants to be considered as one line, I need to say where I'm done. Easy stuff, right? So the computer reads, when I told you, when I assign variables, from what direction to what direction? Right to left. Right for you to left, right? But also, does it start here, then it goes up and then down? No. Inside this curly brackets, which are my lids here, it's gonna read from top to bottom. So the computer reads top to bottom, right to left. We'll talk about some times when it's not true, but not for now. When it does loops, or when we'll talk about the order of precedences next week or the week after. So we have this end of statement. Now the computer said, okay, you want an integer. Computer knows, oh, an integer is 32 bits. Here, it's 32 bits for you to use. And then it'll say, okay, now you can use it. I can say x equals 5. Is that like that? No, I need to say I'm done here. So everything has to have semicolon at the end. Right? So can I assign it before I declare it? No. This cannot be before. Computer reads top to bottom. I need to know I have what I want first. Oh, I have the space I need before I can use it. It's like trying to move to your new apartment without having the keys yet. You need to have the place where to go first before you can move. So this is an object called my class. So the word object and the word class could be interchanged. So far so good? Alright.
Question. So the videos you put on Blackboard, do they cover pretty much all we've learned in this lecture? Or most of it?
Well, those are for C.
Or
What? This is Java. This is a different class. But there's some concepts there that I would like you to have that if you didn't take 119, you're missing.
Yeah, I didn't take any programming.
So yeah, so if you watch those and can understand my accents on YouTube, then it'll help you. They're not Java programs at all, but the syntax is similar, and the way the computer works is the same. So when we talk about files, the file structure is not a Java file structure, it's not a C++, it's a Windows or the operating system file structure that we follow.
Thank you.
So, I mean, you can just watch the first one, you know. I talked to you how to convert from binary to decimal and decimal to binary. I mean, I didn't go into detail here. I just want you to watch it there. You need it if you're gonna do this for a living. But you're not gonna fail the classes if you don't know it right now. But then I need you to understand exactly how everything works, why things happen, not just see it happen. Well, at least that was important for me when I was in undergrad. Well, like I said, I learned Java for Dummies for 2 weeks because I was a senior at my school. Everything was C++. And then, because I always procrastinate and I didn't read the memo. Or maybe I didn't get the memo. So I show up in my last year of college and getting my bachelor's and realize it has to be Java. I'm like, I don't know Java. Or you can take the undergrad, you know, the intro to Java. I mean, but I have 4 classes already signed up for. And I was like, well, I got 2 options. So I gotta learn it real quick, or delay my graduation another semester, which I didn't want to. So I mean, the concepts, I knew how to program in Java and C++ and even Power Builder and other stuff. I knew SQL, and so it was easy. My first language was Quick Basic, actually, and I learned it in a weekend. I had a lot of coffee and I was awake for like 30 hours until I read the whole book. Necessity is the mother of all inventions. I'll tell you a story about that later. Anyway, so Java has libraries built in. There's a library that interacts with the keyboard, a library that interacts with the screen, with the printers if you have. There's stuff there, and hopefully you only have 1 keyboard. Have you ever tried to plug in 2 keyboards in your computer and see if you can type in both, see what happens? I don't know if it'll work, probably it will work, but or might get one and then you're waiting for drivers to be uploaded. I know in the mouse you can have more than 1. Like in my laptop, I have the pad, and I have the little button in the middle of the keyboard. So I have 2 there. I mean, have you ever tried to move both at the same time? See what it does? That's when you have nothing to do. Well, I guess I had nothing to do when I did that. So I have this big box. So if I have this blue box, and when I access the red box from the blue box, how do I will write it? Well, I have this thing called a dot. And then I can say, whatever's in the blue box, then I should have a list of the things that are inside that blue box. And I could say red box. And then you go to red box and you get another dot. And then you can get what's inside the red box. And then you say X-Men DVD. So you know which DVD you're getting. It's this one or that one, right? So this dot is called simply dot notation. And this dot notation, all it is a way to access things that are inside another library, object, or class, or whatever. So there's a class built in. We call it JDK, Java Developing Kit. It's called System. Oh, and Java is case sensitive. So if it doesn't work, it's going to get you a red squiggly line or a blue squiggly line, depends on what IDE you're using. And I see the system and I say dot. And I say, what do you want? You want the input or the output? Well, I want the output to the screen. So I say out. And what are you going to do? Well, let's put another dot. And I can say, let's print something. Print a line. Now, print line is a method. So this is a method called print line, ln. So if it's a method, what does it need? It needs parentheses, open parentheses. At some point, you need to have closing parentheses. Okay. And what does it what do you want to print? I want to print the number 5. I can type number 5, or I can type the variable that goes in here. Well, I want to print x, and what's the value of x? Well, x is 5. Is that it? Yeah, I'm done. So I need to close parentheses. So, what if I don't want to print x? Well, you can choose whatever you want. Let's print hello world. Let's say what's up world instead. Oh wait, that's just free text, right? If I have free text, how the computer knows it's not the name of a variable, the name of a method, it's actually just free text. It has these things. Double quotes. So if you have just free text, you open like a lid with double quotes, and then you end with double quotes. All right? So the computer knows whether that text is. So,